Hey everyone, good afternoon, good morning, wherever you are, and thank you for joining us today. I am Jennifer Joyce, the Regional Vice President for Sales for the West here at Condusiv Technologies. And here with me today, I've also got my partner in crime, Howard Butler, Senior Director of Systems Engineering. Now, Howard is a 30-plus year veteran here at Condusiv Technologies and an expert in the inner workings of the Microsoft operating system. So, Howard, thank you very much for joining us today.
Hey, Jennifer, thanks very much. Always glad to be here. Hey, everyone, don't let her title fool you. As you know, Jennifer's been with the company for over a decade and is quite technical as well, and you'll see that as we get going along here. Now, one thing I wanted to point out is kind of a quick housekeeping item, and that is this is designed to be really an interactive type of webcast. So please drop any questions you have into the Q&A box over there, and we'll get to them as we go along, or we'll hold on to those and answer them during our Q&A session towards the end. So Jennifer, over to
Great.
you.
Thanks a lot, Howard. Okay, good. So before we dive in, I just wanted to hit one other real quick housekeeping item of how we're going to organize today's webinar. We're really going to put this into two parts. In the first section, we're really going to call that our executive briefing. And what we're going to cover is going to be kind of the high level view of what we do. We're going to go over the use cases. This will be the first 15 or 20 minutes, go into how you could evaluate the software. And if you need to drop off after that, you'll have the core of basically the benefits that the software can provide and what it can do for you. In the second half, we're going to go into the deep dive technical briefing portion. So if you really want to get into under the hood of how exactly we do this, then stick around for the entire presentation. But we've kind of done that to really be respectful of your time today. So let's jump into this. We're going to talk about some of the challenges that it does. I went too fast with my slides there. So we're just going to talk about the agenda real quick. So what we're looking at here is we're going to talk a little bit about how we get into this. And you can see that we have a variety of use cases we're going to share with you in Citrix environments, Horizon environments, and so on. So we're going to get just right into this now. So as a company, we're a 39-year-old software company, and that's a long time. So we've been around for a very, very long time. And what I wanted to call out here is kind of what I like to call our scout badges, specifically that we're a Microsoft Gold partner, and we actually have been since day one, since their partner program launched. And we are just one of a handful of companies that have actually had access to the Microsoft operating system source code. In fact, Howard on the call with us is one of our team members who's was there and had that access and gained a lot of really deep insight into the inner workings of that operating system. And that's what we're going to be talking about optimizing today, especially in the VDI context. So I think you're going to really enjoy hearing a little bit more detail from him as we go. What we really want to focus on is the software offering that we're talking about today is called V-locity, one of our flagship products. And we're going to talk about how it literally transforms IO to be more efficient. We're also Citrix Ready certified, and we're also a VMware TAP partner. So let's get into this here. Now, what I want to touch on real quick is, we're all really familiar with the S-curve of product adoption. And, when something hits that 90% saturation rate, it's at full maturity, and not every product's going to get there. We don't even know what products will get there. We clearly have things that have declined. I didn't put a horse and buggy in here, but we did get the Model T Ford, VHS tapes, and floppy disks. So those are way past decline. They're obsolete. They don't even exist anymore, but kind of get a good laugh out of that. But something else that's declining still out there a lot are hard disk drives. We still have a lot of them out there, but they're really starting to be placed by SSD and flash. Tiered storage is at a very full maturity point. We've got individual laptops and clients. All flash storage is very mature, and also virtualization is quite mature as well. We got to watch that spread across the landscape, and it's really neat. We're kind of in kind of a Gartner-esque position here because of what we do, where we sit, and how we work with clients. And we talk to dozens of customers, different organizations, small, medium business to large enterprise every week. And we really have a finger on the pulse of where things are. So we watched when virtualization did this S-curve and went from planning stages to 25% virtualized to 75% virtualized to 99% virtualized. And right now where we are is we've got cloud, VDI, and hyperconverged in the growth curve, and they have various points of inflection and acceleration. And for obvious reasons, right now, VDI has experienced an unprecedented amount of attention in the last month as we have the workforce migrating to home offices. So in January, we were probably here. In March, it's got a lot of attention and it has gone into a hyper accelerated growth curve. So we really understand that there are going to be some barriers to getting VDI implemented, which is why it hasn't previously accelerated on the growth curve. Now let's talk about the benefits first. So benefits, they're pretty obvious. We've got greater user mobility, central management of an image, lower cost endpoints, but the barriers of what have been holding us back. So we're really dealing with a lot of complexity. It's very expensive. The TCO of bringing it in hasn't balanced out yet compared to dedicated endpoints in a lot of organizations. It's difficult to deploy and manage. You have to have a highly technical and skilled team in-house to be able to pull this off properly. And often the end users are resisting it because they're saying, hey, my desktop gives me better performance than this VDI experience. So it's still kind of not in the balance point of wanting to tip there if our environmental factors hadn't changed. But now that those have changed, we're forced into managing this in the most cost-effective way possible. So we really are at an inflection point. VDI is here to stay. Telecommuting is here to stay. It's going to be normalized globally. As workers, our company virtualized about 2 years ago. Our company realized the benefit of the reduced overhead costs of real estate, and employees realized the benefit of the increased flexibility and lifestyle. So we're going to have pressure coming from both sides for this to normalize. And also with that reduced real estate footprint, the ROI and TCO balance now come into play for VDI. So we're really set up to do this. Now, this is really kind of an interesting thing. Recently, I was working with one of my customers, and they are fully deployed in the server environment with our Velocity product. And through conversation, he mentioned that their VDI environment, they were having to probably buy double the hosts because their footprint needed to change. They had about 100 VDI clients on a host. They needed to reduce that to 50 to 60 for a couple of reasons. One is they still were having the Spectre meltdown from a year and a half, 2 years ago. They lost 25 to 30% of their performance when they put that patch in, and they never recovered it. And now they're upgrading to Windows 10, and they're just having to go to almost double the hardware. And it was really interesting. I asked him, well, what did the vendor say of this application? And he said, well, they told us to add hardware and assess everything in the image. And as we were talking, I kind of got a chuckle because it crossed my mind. He knows our product very well. We install in the Windows operating system. But I said, it just occurred to me that the Windows OS is in the image. And we started laughing. And he's like, you're right. Because what we can do with Velocity is give you back 30 to 40% more throughput by optimizing the Windows OS, which is a core part of the image. So, this comes into play with our Microsoft Gold Partner certification and our Citrix Ready certification, and also being a VMware TAP partner. Now, I want to jump into the first use case coming up right here, and let's take a look at this real quick. So, Howard, maybe I can actually ask you to speak to this real quick.
So in this chart, we can see some of the test results. And that, it's probably the entire complexity of the testing and data that was sampled. It's probably more than we can actually show here in a webinar or a PowerPoint and stuff like that. But, for the Citrix Ready application, we used iometer benchmarks from Intel running on a Windows 10 using Citrix XenDesktop, and both with and without Velocity in the image running on it. And with the Velocity transaction rates increased by over 90%. So for example, in one test case, IOPS increased from 2,900 to more than 5,500 IOs per second. And so with Velocity and iometer running, the same benchmark, doing the same amount of duration or time, the workload, the amount of data that can be acted upon also increased from 169 gigs up to 273 gigabytes. That's an increase of 60% or more work being done in the same amount of time. So I think that's pretty significant when we look at these numbers.
Thanks, Howard. And I think the debate between iometer and iometer is raging. It depends which side of the Mississippi you're on.
I get caught in that transaction myself.
So, so we're going to jump in here real quick, and I want to cover two things that um, I kind of will call them fallacies or myths, if you will. The first one, let's talk about IOPS ratings. One of the common things that we get asked is, "Hey, I have got." Um, in fact, we did a proof of concept with someone sitting on a all flash pure SAN with a 600,000 IOPS rating, and they still weren't getting the throughput they needed, and they're using a small fraction of that 600,000 IOPS. So when we install their software, we were able to reduce their data warehouse workloads by half. It was running at about 7 hours. We shaved 3.5 hours off of it. So, even on all that hardware, it was pretty incredible. So the myth is I have more than enough IOPS to handle the workload. The reality looks a little bit more like this. Workloads really are processing 30 to 40% slower than they need to be. Now, the source of this is the Windows operating system. It's not the hardware. It's you have a Maserati sitting there in the driveway, and you've got a boot on the wheel. Basically, it's what's happening. And the reason is because of the nature of how Windows structures the I/O. It's split, it's small, and it's random. These are the I/O patterns generated by the Windows operating system. The other thing that I'll touch on real quick, and we'll talk a little bit more about, is that sequential I/O always outperforms random I/O. You can test any hardware you want, all flash, hyperconverged, SAN, SSD, tiered storage, whatever, but sequential I/O will always outperform random I/O. The way things work right now, Windows is actually generating a lot more random I/O than there needs to be. Now, the truth is only a small percentage of total I/O capacity is used at any one time, right? You're not using like 3 to 10% maybe. Now, because of the high IOPS ratings that we have and the perceived speed, and we'll talk about IO response time fallacy here in just a second, we get a false sense of performance confidence due to the high IOPS ratings and the IO response times. So what we're doing with velocity is we're actually working on optimizing the work that's being done, not the spare capacity that isn't being used. And to put an analogy on this, if I were to walk into a room, I'm 5'3", I own my 5'3", I wear flats, very proud of it. If I walk into a room and it's got 20-foot ceilings, there's 15 feet of airspace above me. And let's say this is an incredibly crowded room, and my job is to get to one side or the other without touching anybody else. I'm not going to be able to do that because of how many people are in the room, and I can't use the 15 feet of airspace above me. So that's a great analogy for what we need to do is optimize the working space, the space that's being used right now. We can actually get that to go 30 to 40% faster, but not by focusing on the hardware, but by focusing on the structure of the data. So that's the first thing we wanted to really touch on. Now, the second fallacy that I want to talk to is IO response time. IO response time can be very misleading. Now, what's the myth? The myth is that faster IO response time is better, right? Stay with me here. The reality is that one individual smaller IO transfers faster than one individual larger IO, 4K IO or 64K IO. 4K is going to go faster than 64K. That doesn't mean it's better. It also doesn't take into account the fact that you have split versus contiguous IO or random versus sequential IO. These make a difference in throughput. Now, this is definitely a forest and a trees kind of a scenario here, right? The IO response time on individual IOs being the trees, but the throughput of the overall data, body of data, is your forest. And we want to really focus on the throughput of the overall body of data. So the truth is that individual response time of each IO has been over prioritized in this performance analysis equation. And overall throughput is always slower when data is transferred with this split, small, and random IO profile. And the inverse is also true. Overall throughput is always faster when data is transferred with contiguous, larger sequential IO. So we're going to jump right into the first, well, this is the second use case. The Citrix iometer testing was the first one. So Howard, let me hand this over to you and take us through these use cases. When we get done with the use cases, then we'll talk about the best practices for testing the software, and then we'll go into the real technical deep dive of how we do this IO transformation. So Howard, over to you, please.
Sure thing, Jennifer, and thanks very much. So let's take a quick look at what IO transformation with velocity can do. And we're just going to go through these slides rather quickly. And the nice thing is we can validate this with third-party tools. You probably already have in your environment like VROPS or vSphere and other IO type of measurement tools, which is what we've used in this particular hospital case. The orange represents the measurement taken with velocity, and you can see a pretty nice trend of improvement with write requests per second that's occurring. Now, let's go on to the next slide, Jennifer. Did the slide
Working on it.
advance?
Yeah,
Okay.
working on it. There we go. I think we should have it now. No. There we go. Okay.
There it is. All right. So, well, Shaggy, kind of what's up with this write latency though? It's kind of like what Jennifer was talking about there. If this were the only metric that you were looking at, you would think velocity is slowing everything down. And this ties back to like what Jennifer was talking about with the IO response time myth. So let's see what happens in the next metric. So Jennifer, go on to the next slide. Wait, what? You got your write rate has just gone through the roof once velocity was enabled. So Jennifer, if you wouldn't mind, if you could flip back to the previous slide. And let's take a look at the write latency again. Because sometimes the latency gets up to maybe 3 times longer. But now if we go back to the write rate and examine what is the amount of throughput that you're getting. And so we can see that the throughput metric has improved by 2 to 6 times. That's amazing. That's extremely important. It's not the speed at which you can do a single IO. It's really how much data flow can you get accomplished in the same elapsed time. So this goes to show the fact that, overall throughput of the data and not over focusing on the individual IO response time. So on this slide, we can kind of look at the read latency, and pretty much we've gotten the same kind of flow here. The individual read latency looks to have taken a little bit longer. But as we're going to see, Jennifer, if we go on to the next slide, it's just off the charts. So think about that. So I think as an industry, we focus a little too much on how fast can a single IO be accomplished without actually looking at what is your throughput and actual real use of the data. So let's go on to the next slide here, Jennifer. And I want to throw one more metric up for this particular case, and that's disk usage. And I think pretty much the picture speaks for itself. And just kind of let me mention here, it isn't always about the user experience, okay? Of course, it does usually come down to that, but why do you have the VDI density count set to where it's at today? That's because of end user experience. So when you do install velocity, it would not really be valid just to go back and ask your users, did they notice if anything was faster? You already have managed the end user experience by scaling down that VDI density. But my point here is that as you install velocity, you can scale back up the usage of your environment, keep the end user experience at its optimum, but actually get more work, more VDI clients per system. And that's tremendously going to help the overall environment. So Jennifer, one more thing I wanted to touch upon, if we can go on to this next slide here. And that's how important this concept of IO transformation really is. And I'll go into quite a bit more detail when we get into the technical briefing portion a little bit later on. But I just want to look at this from a high level and kind of sum it up, okay? This is what we want to happen with write IOs, okay? We take those split, small, random IOs, and we can transform them into more contiguous, larger, sequential IOs. That's the key to getting back 30 to 40% of your throughput. Okay, your hardware should be able to perform faster, but the way Windows is handling the data logically, it's like Windows has got its foot on the brake of that, brand new Maserati you just bought. So think of velocity as pressing down on the accelerator, making things go faster, more transactions, larger transactions, more data flow. So now, Jennifer, let's look at our third use case. Now, we're not going to spend a lot of time on this one. It's another Horizon environment. It's running on a pure all-flash type of storage array. And again, tested with VROPs. And these numbers are from a Fortune 500 company. In fact, it's one of those household name cable companies that I'm sure everybody would recognize. And these were samplings from their data call center. Data usage rate is significantly better, more than double in most cases here. And if we go on to the next slide, we can take a look at commands per second. This also has improved significantly. Again, more than double in most cases. And if we go to the average number of write requests, we can see that across the board, every system has realized a significant increase in activity. And with the write rate, the kilobytes per second, this also shows the number of kilobytes written to the disk each second. And we can see, again, across the board, every system has realized a significant increase in productivity. This would tie back to velocity, transforming those small split random IOs into larger, more contiguous and sequential data type streams. And here we have the read rate in kilobytes per second. And we can realize that a significant increase in activity here as well. So now I got two more cases I want to show you. And then we'll kind of get into the technical weeds and talk a little bit more about what's being done under the hood. Now, we just wrapped up this particular type of study with a customer. It's with a local state agency. And in fact, a partner had brought this to our footsteps here. And the conclusion that we came to is that the net result is that velocity would enable them to run double the number of VDI clients in their environment, and possibly up to 5 times more if they could allocate and add some additional DRAM. So it's much better to over-purchase. It's much better than, I should say, than having to over-purchase and buy more hosts. You're just increasing your hardware footprint, when in fact, we could just make your existing hardware handle more work. So let's take a look at the specific numbers that we were able to glean from here. We have nearly identical number of systems in the workflow here, but notice there was a decrease in CPU usage with a greater amount of activity. Now, I will call out and say memory usage did go up, but that's usage of free, idle, unused memory that would have been wasted anyway. If we can dynamically use a portion of that memory to help things get moving faster, then the results are going to be far less network traffic, allowing you to do more transactions as the workload increases using the same exact hardware. So that's pretty impressive. Now, if we go on to this last 5th case here, this was tested on a load-balanced Citrix terminal server environment. The customer picked 10 systems to install velocity on, and then on another different 10 systems, acted as the control group. Now, the customer tested using vSphere to collect the data, and they sent us back the data. And the conclusion that we were able to draw from this is that they would have a 32% improvement in reads and an 18% improvement on writes. That's pretty staggering. So I think that kind of sums up the use cases. And I hope that, this information's been rather useful and kind of gives you pause to really think about what can be done to make things better in your existing environment. So Jennifer, I'm going to toss it back over to you now.
Great, thank you very much, Howard. I really appreciate you taking us through all of that. It's a lot of information to take in, but I think what really matters most is the proof is in the pudding and how is it going to respond in your environment. So the next steps would be a pre-POC consultation, and in every case of the numbers that you just saw, we hopped on a call with one of our engineers and the client. We talked about how they would want to benchmark it to be able to realize and see the results in their environment. We could set that test plan up. We actually do the proof of concept, and in most cases, we're done in under 2 weeks, maybe 3 hours, 4 hours of time investment. The nice thing about V-locity is that it is a .msi file. It can install right into the image, no reboot required, and you're off and running. And then once we're done, we'll review the results with you and kind of see where we got and how things look. Most of the time we have these types of comments back from people in their server environments, especially SQL, reduced timeouts and crashes, VDIs, increased VM density, just better and more stable application performance, shorter backups, things like that. So, and really having to buy only 8 pounds of hardware instead of 10 pounds of hardware, and the hardware that is in-house lasting much longer. So it really does make a huge difference in the environment. So this is kind of the plan. I'm not going to go through this step by step. We'll certainly let you know that we do have a formal process that is very streamlined. You're not going to be reinventing the wheel every time you do a proof of concept with us. We'll just walk you right through it step by step, and it'll be very efficient. So we're going to go into the technical portion of the briefing now. So we wanted to make sure that we got you the high-level benefits. If you have to transition to something else, we do understand the session is being recorded. We will be sending the recording out to everyone. But now let's dive into the technical portion. So we hope you can all stay with us for this. Now, really interesting kind of stuff coming up here. So this is really a profile of what we're looking at for the unhealthy IO. It's split, it's small, it's random. And this is really not what we want. As great as virtualization has been for server efficiency and for bringing the VDI space in, one of the biggest downsides to virtualization is that it really has added a lot of complexities to the data path. And this is what the IO stream ends up looking like. So there are 2 severe IO inefficiencies contributing to this. The first one is kind of what we've been pounding on for the first half of the webinar, is what we refer to as the Windows IO tax. It really is Windows creating this IO characteristic that's much smaller, more fractured and random than it needs to be. And it's kind of the perfect trifecta for bad storage performance. It's this death by 1,000 cuts scenario kind of eating away at the environment. Again, as we covered, what can you do about it? Throw more hardware at it, optimize the image, which we all know really can't be done. You're not going to go rewrite code, and you've already got all the applications in there because you think you need them. So the only other thing in the image left to optimize is the Windows OS. And we do a lot of the over provisioning, all the excess IOPS we talked about earlier, focusing on IO response time, which are 2 of the fallacies. We can actually get a lot more out of this Maserati that we put in there. Now, the other thing that we want to look at is called the IO blender effect. This is that second IO penalty, also AKA IO contention. We all know what this is. It means that the workload from VDI client number 1 or server number 1 is being impacted by the workload from client or server number 37. Whether they're related or not, they are sharing the same hardware. And even if they're not on the same host, they're sharing the same backend storage. And that can be really tough. One of our most common use cases is SQL. I'll give you a real quick example of SQL. We did a proof of concept very recently on an environment that was 6 hosts with 120 SQL servers, and they deployed to 1 server. It looked just like this, and it was that they were missing an SLA with that client every month, and it was costing them a lot of money every month and a penalty back to the billing on that client. And we told them it's not going to work. We're 99% sure it won't work because of the IO blender effect. So they did it anyway. The next month, it didn't work. The next month, we begged them, please give us as many of your heaviest IO servers in this cluster as you can. They gave us 10. They made the SLA by 3 minutes for the first time in over a year. The next month, the software was removed, and they missed the SLA by 5 minutes. And then the 4th month, they put us on 119 of 120 servers, and they made the SLA by 17 minutes. It was phenomenal. So we also were able to verify in their change control process that velocity was the only change being made. The reason I bring this example up is because it is a textbook classic case of the IO blender effect getting in the way. So like I said, as great as virtualization has been for efficiency and cost savings, it really does add a lot of complexity to the data path, and it adds latency as well. And this is what healthy IO should look like. We get this optimum IO profile. We get contiguous large sequential IO. And this is what's going to give us that 30 to 40% improvement in throughput of the overall body of data. So let's take a look at how velocity does this and what it looks like. And guys, as you have some questions, please start dropping them into the box, and we'll be getting to the Q&A section here very shortly. So let's take a look real quick. Where do we sit? So velocity is 100% software. As you've gathered, it is for Windows. It installs directly in the Windows operating system. And it really is just two light filter drivers, right? There are two main engines that we use for optimization. And what we're going to be doing is looking at the fact that the compatibility is very important. It sits above everything else in the environment. It's above the hypervisor, the server, the networks, and storage, and so forth. And it's compatible with the whole environment. Because we're fenced by Windows, and that's where we sit, we don't need to worry about talking or interacting with everything else. Everything else is also compatible with Windows. Like there isn't a flavor of Windows for Dell or a flavor of Windows for Nutanix or NetApp. Windows is Windows, and everybody else is compatible, so we're good to go there. But the most important point of this slide is the title of it, the top of the stack. It's the fact that we're hitting this at the source, not the symptoms. And we treat the breakdown of IO and other inefficiencies right there where it's happening. So that's what's alleviating all of that small split random IO from having to go down through the whole stack and everybody coping with that disorganization and having to overwork to process IO that's a lot smaller and more randomized than it needs to be. So let's talk a little bit about velocity IO transformation for VDI specifically. So with the right optimization, what we're looking at is that transformation across the boards of all of the clients at once. You can install it right into the image. And on the read optimization, we're going to talk a little bit more about the engines of how we do the read optimization. So first of all, if it wrote clean, it read clean. So that's already taken care of. But there's a secondary engine, the second filter driver, that does DRAM read caching. And we'll talk a little bit more about that technically of how that works. And then we'll show you a little bit of the reporting. So let's get into the weeds here on the right IO reduction. Now, Howard, let's cover this together. This first engine is called IntelliWrite. And really, I think this one's fascinating because we've been talking so much about IO transformation, and this really is the core of what we do to transform IO. Would you talk to this just a few minutes for us and take that technical deep dive for us?
Sure. So when an application is requesting to open a file, write some data, it's not talking directly to the storage. It's got to send that request through the Windows operating system, and more specifically, the NTFS file system. Now, NTFS is really a logical representation of the physical storage, okay? So Windows, in all of its capabilities and wisdom, though, doesn't really have any idea of how large the file is going to be, how much space is needed, and it doesn't have any intelligence to go look for the largest segment of free space to write your data. So when an application sends the IO request to Windows, and Windows now is going to process it, it grabs the first available chunk of free space. And if that chunk of free space is really large, great, no problem. It can write the data and go on to the next particular type of task. But over the course of time, as you use that particular storage array, continue to use Windows, you're creating, deleting, modifying existing files, the free space gets chunked up into little tiny segments. And as I mentioned, since Windows isn't looking for the largest possible chunk of free space, has no real knowledge of it, Windows can only grab the first available segment. So if you're trying to write, let's say, a 64 KB chunk of data, and the next available chunk of space is only 4 KB, Windows will allocate that 64 KB or excuse me, that 4 KB segment of space, write what it can, realize that it has not yet completed the entire write operation, but it'll send that IO on its merry way. And then it's going to go and grab the next available free space. Write what it can into that space, send it on its way, and go grab the next available free space. So your application sends one IO request. Windows may translate that into dozens, if not hundreds, thousands of separate individual small IOs. Every one of those IOs takes a separate amount of time to complete. So rather than letting Windows haphazardly handle that type of activity, we provide the intelligence to the Windows file system such that it now becomes aware of where are the larger chunks of free space, what is the behavior of your applications in terms of how much space are they going to need for a particular file, and armed with that information, our intelligence back to the Windows file system can make far better choices in writing the same amount of data, just using fewer individual separate IOs. So you can riddle me this one, Batman. Figure out what is going to be more efficient. Do you want to do 1,000 tiny random IOs or a handful of really large, more productive IOs? You're going to find that those larger ones are going to be far more efficient and get the work done much more quickly. So however you write the data, you're going to get a benefit on reading it back. So it's really handling both reads and writes in kind of one motion here to improve productivity.
Great, thank you, Howard.
Sure.
So we're going to jump into the second engine here, and this is IntelliMemory. Now, IntelliMemory is a completely different animal. So, just kind of touching back on IntelliWrite real quick, as Howard was alluding to, so that engine, just so you know what it can do, the IntelliWrite engine alone will reduce IO by about 30%. So if it was going to take 100,000 IOs to write 1 gigabyte of data, which is pretty close to what it takes, we've analyzed thousands of servers, the telemetry data back from thousands of servers. It takes about 100,000 IOs to write a gig of data on average. We can cut that down to 70,000 IOs per gig of data. That's fantastic. So that's what that means. And that means also that if it wrote with 70,000 IOs instead of 100, it's going to read back that way too. But there is a secondary read optimization that we can layer in on top of that, and that's with our DRAM read caching. We're about to start talking about memory and caching, and I just want to be clear here that the caching is only on reads. Again, I'll repeat that. The caching is only on reads. We are not buffering or using memory for any of the write optimization that we just talked through. All the write optimization is completely passed through. In the event of a power outage, data is going to get there safely. We get that question every single time, so I'll just answer that now. So the IntelliMemory piece, as I was talking about, is a read-only cache. And there's a couple of things I want to mention about it. Well, we like to refer to it as our tier 0 caching strategy, because you're leveraging DRAM right within the VDI client or the server VM, either way. And the real genius of the engine is that it is completely dynamic. In fact, I'm just going to go ahead one slide here kind of to illustrate that. This is the slide that we use when we're talking to folks about SQL, because SQL will tend to take a lot of memory, but this is completely dynamic. And the nice thing about it is that we have to leave a certain amount of free space free at all times, and we'll instantly release that memory back. The software is checking every second, and we're never going to drop into paging because we leave that free memory section, the white space that you can see, free at all times. So the system's never going to be tricked into thinking that it's running short of resources. The other thing, Howard, maybe you could talk to real quick, is what it is that we're caching. It's very selective, so it doesn't take a lot of memory to be effective, correct?
That is correct. We studied what's really causing the bottlenecks from an IO perspective. And, we're not trying or attempting to cache everything. In fact, we're rather selective. And rather than just throwing stuff into the cache, cross your fingers and hope that, we've made all the right decisions, we just decided that wasn't really good enough. So we have specific analytical behavior type of processes in here for the product to really truly recognize what are the most frequently requested read data requests. that are kind of small and causing a lot of the problematic type of throughput issues. And if we can satisfy those IO requests directly from memory, well, you're getting quite a few levels of benefit here. Memory to memory data transfers are like, 12 to 15 times faster than going to even flash or SSD. So it's far faster than going to your storage. And since they are the most frequently requested data items, it must also imply that they are the most important. Else, why are they occurring so frequently? So getting those out of the way and satisfied more quickly allows for the applications to continue on queuing up additional IOs and process more data. So you can get a greater amount of workflow with just a small footprint of memory. And again, something that is dynamic. We're only using memory that would otherwise be free, idle, available, unused memory, and leaving plenty of memory available and recognizing that if there is a demand for memory, we'll release memory out of our cache, give it back to Windows. So no application, Windows isn't starving for memory, and it's a really good balance of resource utilization.
That's great. Thank you very much, Howard. And guys, I know we've gone a couple minutes over here, so we're going to go through the last 4 or 5 slides here pretty quickly. And again, if you have any questions, drop them into the Q&A box. I do see a couple in there, so we'll get to those in just a minute. So the next thing I'm going to show you, and first, well, I'll get there in a second, but I just wanted to bring this in real quick. So we actually, two anecdotals. Last year we were meeting with customers at VMware, and one of them said to us that they've got several thousand VDI clients, and they're an existing customer. They've got us across their server infrastructure on about 350 or so servers. And they met with us about their VDI environment, and they said, we defragmented the gold image of our VDI environment, and we recovered 25% of our performance instantly. Now, it's interesting. The reason I bring that up is because VMware's recommendations here, as you can see from a document by VMware, the link is right there, their disk IO performance enhancement advice. The second bullet point says defragment the file systems on all guests. Well, guess what? With the IO optimization and IO transformation technology we're talking about, you do not ever have to defragment the file system again on anything, a server or VDI client images. The reason is because the fragmentation is simply not allowed to occur. We have literally cut it off at the pass before it even happens. So we've literally transformed the way that Windows addresses IO. So that meets that second requirement beautifully. And on the first requirement, or recommendation, I should say, it says increase the virtual machine memory. It should allow for the operating system to cache more, which offloads IO. Well, we all know that the operating system isn't going to cache more. It already has plenty of free memory, but we can use that memory. If the OS missed it, we'll see it, and we can serve that IO directly from the VDI client or the server, and that's going to offload more IO. We've been talking about IO transformation a lot, but what we haven't talked about is that by transforming IO, you have far less IO, and that means that you're taking out a lot of pressure. Again, we're talking about that room analogy where I'm walking through the room and I'm only using 5 feet of that space. Now I can use that 5 feet of space very, very efficiently. So if half the people have left the room and the rest of them are all now sequential, I can walk right through the room and accomplish my mission directly in just a few seconds walking across that room versus not being able to move through it at all in the first place. And this is what it looks like. So when you combine the two engines, I'm going to read this from right to left. So the right IO optimization around 30% average. If it reads clean, if it writes clean, it reads clean. So in that 60% optimization number you see for read IOs, about half of that is from the effect that it wrote clean, it read clean. The other half is going to be from the DRAM read caching. And you can also see a nice view here of the storage IO time saved, representing that throughput savings as well. And we also have central management for all server environment, VDI environment. You kind of one ring to rule them all right here. And that's the presentation, guys. So I do have a couple of Q&As here. We're going to take these quickly and drop any more into the box you may have, because as soon as I get to the last question, we will go ahead and shut down the webinar. But the first question, Howard, I have here, is there a limit to the number of VDI clients we can deploy this to?
No limit whatsoever. You can put it on as many VDI clients as desirable.
Okay. Let me see what's the next question here. It says, what kind of memory footprint does this take?
As we've spoken, the memory footprint is extremely small. It's only using memory that would be otherwise free, idle, and available. So the net result is that there really isn't any additional memory that's used.
Okay, great. All right, I've got another one here, Howard. It says, does this get installed on the hypervisor?
Our product is designed to run on the Windows client machines, the guest VMs or VDI clients. Any Windows operating system will benefit from what our product can do. And so in certain instances, yes, the host can derive benefit, but only for those dual role or dual purpose type of host systems running Windows.
Okay, great. And Howard, this is not a question in the Q&A box, but just one that I'm going to add on because we get asked a lot since this last one was about hypervisor. We often get asked, does it matter what the hypervisor is? So if they're in a Horizon environment or a Citrix environment, or that's kind of the question we get a lot.
Yeah, no, it makes no difference to us. Again, because we focus on installing inside the Windows guest virtual machine.
Okay, and then here is the this was the last question. Another one just popped into the box, which I'll get to in just a second. The penultimate question now is, does it matter if these are persistent or non-persistent?
No, we work equally well with both type of VDI client environments.
Okay, great. And then the last question is probably for me. It's how is this licensed per host, per VM, per site? It is licensed per host. So it's an all-you-can-eat model. You purchase the host license and you can deploy it into the master image of the clients. Okay, Howard, I don't have any other questions in the box. So I want to thank everybody today for attending the session. We will be in touch with you to schedule your consultation. And it's a very, very easy process. You could be into the proof of concept by tomorrow. So thank you very much again, and stay safe, everyone. And Howard, thank you as well for your time today, too.
Thank you, Jennifer.